Element number 11 on the periodic table is sodium. The atomic symbol for sodium is Na. Sodium is a soft silver-white metal that oxidizes quickly in air and reacts explosively with water. Sodium's unusual atomic symbol, Na, comes from the word natrium, the Latin name for one of the compounds sodium is found in. Sodium is classified as an alkali metal, and it lies on the third row of the periodic table, called period 3. Each atom of sodium consists of a cloud of electrons surrounding a compact nucleus that contains almost all the atom's mass. In the most common form of sodium, its nucleus has 11 positively charged protons and 12 uncharged neutrons. Sodium has 11 negatively charged electrons to balance its 11 protons. These electrons are found in 3 shells surrounding the nucleus, which can be visualized as being built up from the nearest preceding noble gas, neon. Neon has 10 electrons distributed in 2 electron shells. The single additional electron in sodium is found in the spherical 3s orbital shell. Sodium, like the other alkali metals, is highly reactive and loses this lone valence electron readily. Pure sodium has a silvery white appearance, but tarnishes easily in moist air. Sodium must be handled with gloves because it is highly reactive with water and can easily cause burns. Here, 50 grams of sodium are loaded onto a device on a platform floating on a lake. The device has a pail of water and a hinged arm holding a crucible above it, which can be released from a safe distance. When the sodium is dropped into the water, it will instantly generate a large amount of heat and release a cloud of hydrogen gas. The hydrogen gas will rise and mix with oxygen in the air to form an explosive mixture. The heat from the reacting sodium then ignites the hydrogen and the mixture explodes. The same experiment was repeated at night using 200 grams of sodium, and the reaction is even more spectacular. The compound sodium chloride is the chemical name for table salt, an important part of our diets. Sodium is used to make batteries and glass. Sodium vapor goes into streetlights. And liquid sodium sometimes cools nuclear reactors. Sodium is also used in agriculture and medicine. Island life has definite benefits for people who enjoy living near the ocean. But one of the drawbacks of living on an island is that residents must be fairly self-sufficient. If they run out of essential supplies such as food or water, it can be difficult and expensive to import them. That's just the problem the people of Santa Catalina faced when their island community began to run short on drinkable water. Catalina is an island off the coast of Southern California. Recent booms in population and tourism were great for the local economy, but also pushed the community's water supply to its limits. There just wasn't enough fresh drinking water to go around. So residents turned to the ocean to meet their needs. Anyone who has ever accidentally swallowed a mouthful of seawater knows that drinking too much of it can make you sick. It's undrinkable because, unlike fresh water, seawater contains over 70 different minerals dissolved in it. The vast majority of these minerals are chloride and sodium. Sodium atoms have an extra electron in their outermost shell, while chlorine atoms are one short of having a filled outer shell. As a result, when they come together, sodium donates its extra electron to chlorine, and they combine to form sodium chloride. Sodium chloride is otherwise known as salt. But if you can separate the salts from seawater, you are left with pure, fresh, drinkable water. The process of removing salt from seawater is called desalination, and it's just what the people of Catalina are doing. Hebbly Beach was the first commercial desalination plant. The plant uses a process called reverse osmosis. Reverse osmosis involves high-pressure pumps pushing seawater through a semi-permeable membrane or synthetic filter. As water passes through the membrane, the salts and other minerals are left behind.
What we're doing is we're taking fresh seawater, we're pressurizing it to 800 pounds per square inch, and we're pushing it through a semi-permeable membrane. It flows through this channel here that looks similar to a screen door. Then the fresh water is squeezed through this semi-permeable membrane to a wick inside and flows around and comes out the product. And all we're doing is squeezing out the fresh water. So we call it fresh squeezed water.
The semi-permeable membranes have microscopic holes that allow the smaller elements, such as hydrogen and oxygen, to pass through. But the larger molecules of sodium and chloride are stopped in their tracks. For every 30 gallons of seawater pumped into the plant, about 9 gallons of drinkable water come out. The leftover salts and other materials get pumped back into the ocean. This desalination plant produces about 200,000 gallons of drinkable water every day. That's about 20% of the island's total drinking water. And it's all courtesy of our growing understanding of the unique chemistry of seawater.